Corporate finance practice problem within OneNote for the future value, or FV, which we're going to calculate in many different ways. One way including the mathematical formula, a second way considering the formula that could be calculated in Excel, and a third way which would be using tables or future value tables to help with the calculation. Don't leave profit solely to chance. Instead, use corporate finance. Here we are in OneNote. If you would like to follow along in OneNote, you're not required to, but if you have access to it and would like to, we can go into the tab on the left-hand side. We're going to be in the practice problems section, and then in the problem of the 911 future value FV multiple forms of calculation. I'll then close this item up so we can be focusing in on the practice problem. Our data is going to be up on the left-hand side, and then we'll work through that data with basically the blue areas on the bottom. Note our data here, we're typically going to be thinking, when we're thinking future value, kind of like the opposite of the present value. When we're thinking present value, we're taking something that's going to happen in the future, basically, future cash flows, trying to bring them back to the present. Now we're thinking about something that we're putting in place now and thinking about where it will be if we have an investment that will be into the future. So the typical kind of scenario, thinking about, say, investments in like stocks or something we're going to get a return on, and we hope we get a return on, what kind of return we might get, where we would then be, what the value will be in the future value, using future value, basically dollars at that point in time. To do that, we're going to need the amount that we're going to invest. We're going to need the period that we're going to be invested over, which may be determined or given to us in years or months, typically. And then we're going to be needing the percentage of the increase and the compounding of the increase that we believe is going to be then taking place. Once we have that, we can then calculate the future value, where we expect to be in future value terms at the end of this time period. So our data is going to be on the left-hand side. We're going to invest the 10,000. The years are going to be the period, 3 years, and the percentage is going to be the 8%. We could do this multiple ways, and we'll check it out multiple different ways, including our formula. And then we'll think about tables. So the tables that we used in the present value, similar kind of feature. That is a common feature that's going to be used in test problems, because that eliminates kind of like the calculator or the more complex calculator needs that you might have if you have the table. You might also do it with a complex calculator or something like Excel. So that's the other way that we will consider it in practice. I believe that's one of the most efficient ways to be using it, would be something like Excel to help us with these calculations. Also note that it's useful to break this out, as we'll do in a little bit more detail here, to look at it kind of like a year by year to see what happens from a year to year. Because even if you use the math, the formula here, then it's still kind of a little bit magical. You do the calculation and you get to this magic number at the end. If you actually calculate it with a year by year or period by period calculation, which is fairly easy to do if you have something like Excel, and I do recommend working this problem in Excel, we do have it available, then you get a bit more understanding of what's going on just from a conceptual basis. So the future value calculation then would be future value equals the present value, which is basically the amount that we're going to be investing now, times 1 plus R, R being the rate of return. In this case, we got the 8%, and then that's going to be to the N, the number of periods, in this case, 3 years. Remember that you want to make sure that you know what type of periods you're talking about with regards to the time period. Are we talking years? Are we talking about months? And so on and so forth. Now, we're going to calculate this 1 year at a time. So I'm going to do the future value not for 3 periods first. We'll do it for year 1, and then we'll do the same thing for year 2, and so on. So we'll first use the formula. I'm going to break this formula out into a more like a tax return type of format, right? A vertical type of format. And I think this is useful for building things in Excel. If you were to build something in Excel and you wanted to see how it works, it's nice to have this formula broken out from an algebraic type of equation to a table. So I think that's a good thing to work with, and you might want to actually do that in Excel, work through the practice problem in Excel to put that together. Obviously, you can just use the formula, the algebra here as well, and work it through in the algebraic format. So if I go back up top, we're going to say the present value is going to be the 10,000. That's going to be the PV that we have up top. There's the 10,000. And then we've got the 1 plus R to the N that we're going to calculate. So we got this piece that we have, and now I'm going to calculate the second piece in our table here. So the second piece is going to be 1, which is going to be this 1 right there. And then we're going to say at the rate, we're going to add the rate to it. So 1 plus the rate the rate being 8%, so 1 plus the rate would be 108%. So now we've done this inter portion, 1 plus r. And then we're going to take the number of periods. I'm not taking 3 in this case, I'm taking 1 because I'm just looking at 1 year at this time. So we're going to consider the 1 year, that's where that 1 comes from, times 108%. That then is going to give us our 10,800, which would make sense if we did the calculation here. Of course, we would take the 10,000, if I'm making 8% on the year, 0.08, then we've got the 800 plus the original amount of the 10,000, that would be the 10,008. So you could do the same thing by saying, I'm going to multiply this by 108%. So 100 would be 1 plus 8%, 0.08. And so let's do that again. 1 plus 0.08, that would be 108, 108% times the 10,000. And that would be our 10,008. That's where we would stand then at the end of that time period. Notice that's in future values. When we're considering the future value, we got to consider, what does this percentage mean, this rate mean, and we want to be considering how are we going to, come up to that rate. Obviously, that's going to be kind of a projected type of thing most of the time in terms of what we think the earnings are going to be for a possible type of investment. So then if we go down below, we could do this on a period by period basis and consider this calculation period to period, which can be a little bit, give us some information. It's easy to do basically in Excel. So I think it's worthwhile to do in Excel, and it's fairly easy to do a running balance type of calculation. So we'd get the 10,000 and then you got the 800. Obviously the 800 is calculated by the investment of 10,000 times the 0.08. There's the 800. If you add that to the 10,000 plus the 10,000, that's going to give you that 10,008. Then if you go to year 2, then now we're taking that 10,008 has now compounded. It's the way we're calculating this, right? So now we got the 10,008 times the 0.08%. That means that the amount of return for year 2 is 864. If I take that 864 plus where we were at before, 10,008, we then get the 11,664. Then if we do that again, we're going to take that amount times the 0.08, and that's going to give us the 93312. I'm going to add that to the 11,664, and that's going to give us our 12,597. And so then our total of the interest is going to be the total of these over that time period. So note, this is a little less magical. If I was to do the formula for this, I'd still come up with just like the magic ending number, which we'll do later. We only did it for 1 year before. Later we'll do it for 3 years to get to that 12,597. But it's useful to do this, and if you have Excel, it's quite easy to do this kind of running balance type of formula and get a better perspective of what is happening from period to period. You could do it slightly differently over here. If we took then the 0, we got the 10,000, and then we're just calculating the interest on the right hand side. So now we've got the 800, and that brings it up to the 10,008. And then once again, we've got the 800 on the right hand side, the 864 on the right hand side to give us the value of the 11,664. Basically the same kind of concept, that you could do it a little bit differently or calculate it or do the formula possibly a little bit differently in Excel. We'll do that more in Excel in our Excel problem. I do recommend working it in Excel. Note, you can also do this calculation with a calculation in Excel, which would be similar to doing this in a calculator, a financial calculator, as opposed to a normal calculator. And many people will do this method, and like the math formula, it kind of magically gives you that end result. It'll magically get you to that end result, which in this case we're using one period, which will be that 10,008, because we're just using one year later. But again, if you were to run this and it had multiple periods, it's kind of nice still to put it in Excel and see the detail of it, see what the interest difference was going to be from period to period as you think about this. But the formula is going to be something like this. You could do it in an Excel formula like so. The future value, and I'm going to put a negative in front of it, is going to be brackets, and then you'd find the cells of B3, comma 1, comma 0, comma B1. Again, we'll talk more about this in Excel when we can see the formulas and the relationships of them. But also just realize that when you do that in Excel, you can break this down into basically a function table within Excel, which means it'll give you the rate. So then we would put the rate here in our practice problem, which was 8%. The number of periods was 1. Notice that we're looking at periods here as an entire year. If we were looking at periods that were a month, then we would have to take the rate divided by 12. The period has to equal the rate amount. We usually think of rates in terms of years, and so if we're talking about a period of something other than a year, such as a month, we got to make sure that we break down the rate to be relative to that by taking the yearly rate, which is typically given, and in that case, dividing by 12. But we're talking yearly rates here, so we just take the rate, and then the payment amount. We're not making payment amounts. That would be if we had an annuity type of calculation, multiple payments, thinking about considering multiple investments, which we may talk about in the future. But here, we're just going to put a 0 there, and that's why we could use the same function for both Excel and for the two calculations, for the future value of an annuity and the future value of 1, which typically with annuity tables or with the tables, you need two separate tables. With Excel, you can use the same formula, in essence, a future value formula, because you can put basically a 0 on the payment here and then use this one, which would not be required if it were an annuity, but is required if it's a present value of 1, and that would be B1, or the present value or the amount of the investment of the 10,000. And that'll give us our calculation here, which you can see is the 10,800 on the calculation. Notice that if you get good at this, you stop using this table and they give you this little thing down at the bottom when you start to enter the formula. And that's usually a lot faster, and you can use that once you get good at the investment. You got the rate, comma, the number of periods, comma, and then the payments, which is 0, you can see here, and then the present value, which we picked up the present value in the cells. So then we have the table for the future value of 1. We can also do this using the tables. So here's the tables down below. As you do the tables, you got to make sure you're picking up the proper table, which is part of the problem. Oftentimes when you're doing this in like a book problem for a test or something like that, because there's present value tables. If I was trying to take the future period back, there's present value annuity tables, there's future values of annuity, and there's future values of a single component. So you want to make sure that you're picking up the proper table. Once you have the proper table, then you can basically say, okay, I'm going to take the amount, the 10,000, times the amount that I'm getting from the table, which would be based on the percent and the periods. Once again, be careful if you're talking about periods in months or years. Here we're talking years, and I'm not looking at the 3 years, just the 1 year we'll start off with, and then we'll add 1 year at a time. So 8% 1 year is going to be that 1.08. There's the 1.08, once again getting us to that 10,800 for that 1 year time period. So multiple methods to get to the same spot. If you're talking to different people and they're using different methods, make sure that you realize they're doing the same thing. They're just doing a different method. And many people only have one method in their mind, So if you do it something different, or you try to talk to them differently about it, they're not going to know what you're talking about. So you got to know what they're talking about by knowing that whatever they're doing is just one method of doing the same thing here. So let's do a similar type of thing for 2 years now. So we'll do the formula for 2 years. Here's our formula, same formula, but now we're going to say 2 of the 3 years have passed. Present value is the 10,000. Then we'll calculate this interpart, 1 plus r to the n, which is going to be 1 plus the rate of 8%, giving us the 108%, now to n, which is now 2 years. Here's the different factor, it's 2. So if we do this calculation, and I changed the calculator up top to a scientific calculator, so if you use a Windows program, they should have a scientific calculator so I can take it to the power of 2. We do have a power of 2 here, but I'd like to be able to do it to 3 next time. So I'm going to go ahead and take the scientific calculator out to do so. So once again, we'd have 1 plus the 0.08, and then we're going to say that's going to equal the 1.08. And then I'm going to take that, and I'm going to, I could hit this one, but instead I'm going to hit this item down here, and then that puts the little caret up top to the power of 2. And that's going to give us then our 116.64, and then I'll take that times the 10,000, and that'll give us our 11,664. So that would be after the 2 time periods, in this case, those time periods being years. Once again, if we did this in our little calculation here, we got the 10,000 plus 8% we saw before would be the 800. Now we're at the 10,008 after year 1. Now it's year 2. We have then that 10,008 times the 864. That gives us to our 11,664. That matches our 11,664 up here. So note, you can do this running table down here in Excel, which again, I think is useful to do. You can look at it in that format, or in this format. So then scrolling down, the next thing we could do this with Excel, which is similar to a financial calculator, which should get us once again magically to that end result. You could see it in this format, which would be the rate being the 8%, and then the number of periods. This time I'm taking 2 of the 3 years, comma 0, which is the number of payments, because we're not making payments. We're saying this is going to be just a future value of 1, and then we're going to take the present value, which is the 10,000, and that would then give us once again our end result, in essence being that 11,664. So then we have the future value tables that we could use. So future value table, same calculation for 2 periods now. We take that 10,000 times the amount from the table, making sure we have the proper table, the future value of 1 table. And now we're looking at that 8%, making sure that when we're looking at the period side of things, we got the proper period, in this case being years, so 2 years. And we have the percent for 2 years, and that's going to give us the 1.1664. So 1.1664 here, 10,000 times the 1.1664 gives us the 11,664, matching what we have up top, 11,664 and the 11,664. Note that the tables could be off a little bit because this ratio or this number might be rounded. So you could be off a little bit by the different use of these methods. The math would be the most accurate as long as you're rounding or full or not rounding all of the calculations as you go through. When you use the table, you're going to round. If you do this in Excel, Excel will not round if you're using ratios, even though it'll look like it's rounded, because it won't show all the decimal points in the number. For example, it might cut this off to like 2 decimals, even though it's the full number that you're using to calculate. So be careful of rounding with these kind of calculations. So next we have 3 years. Let's do the same thing for 3 years now, the full thing. Now we got 3-year investment. Present value is going to be the 10,000. Now we're going to do this inner part, which is going to be then the 1 plus the 8%. There's the 108%. Now we have n to the power of 3 this time. So if we do that quick calculation, we've got, okay, scientific calculator is what we need now, which I'm not as used to. 1, and then I'm going to say plus the 0.08. And then I'm going to take that and say, now we got the 108. I'm going to take that to the power with the little caret comes up here, little caret of 3. And that's going to be, if we move the decimal point over, 125.97% or 1.2959712, so on. And if we take that times the 10,000, we're going to get that 12,597. So note that 12,597. If I was to build my table, like you might ask, where do they get in the future value table? If I took that number and divided it by the 10,000, that's going to give us our 1.259712, which should be, I believe, the amount that would be on the future value table, which we'll take a look shortly. So then if I go back down, we're going to say, now if I did this in terms of Excel, which would be similar to a financial calculator, we would take then I believe the first one's the rate. I don't have the little description here. The rate, and then comma, we would then have, I believe, the number of periods, which in this case would be 3, and then the payments, which is 0, which you can reflect by having, instead of a 0, just 2 commas, which would then take you to the present value, which I believe is the 10,000, once again calculating the same amount. We can use the tables then, which would, let's just delete this, the 10,000 times the rate. That rate, 1.2597, close to the rate we got up here, 1.259712. So notice the table's going to round it down to how many decimals? 4 decimals. So there could be a rounding difference. So same thing here, we got the interest rate. Make sure you're lining up the interest rate with the periods. So the periods happen to be years. These rates then will be, the rate per period, in this case years. So we got the 8, and then here's the amount for 3 years. That's the 1.2597. There's the 1.2597. 10,000 times that 1.2597. That gives us our 12,597. That amount should match or be close to the 12,597 here, although it doesn't match perfectly because the table's rounded. So actually the calculation up here, if you did it in Excel or something like that, because you're not rounding the decimals in Excel or using a formula, will actually be a little bit more exact, which may not make a difference for decision-making purposes, but could make a difference for practice problem or test questions or things like that. So you want to be careful and make sure that you're using the method. It also could be a point of differentiation if, for example, the book is trying to get you to use the tables and try not to get you to use the calculator. Then they may put that difference in. They may say this is the right answer, because if you choose the other one, which is more exact actually, that means you must have used another method to get to that answer. So they could try to force you not to use another method by making you, put in the answers related to the difference in rounding, so that they can kind of force you to use the method that they told you to use within it.